Here's sample test 4, problem number 5. It takes 1 year for the Earth to travel around the Sun, 3.16 times 10 to the 7 seconds. The Earth has an average orbital radius of 1.5 times 10 to the 11 meters. Using Kepler's third law, determine the mass of the Sun. Note the gravitational constant, 6.67 times 10 to the minus 11. Right, Kepler's third law states that the period of time for a satellite squared is equal to 4 pi squared over g times the mass of that central body, in this case the Sun, times the average radius of the orbit of the satellite cubed. So that is Kepler's third law, and we're told that the period of time for the Earth as a satellite is approximately pi times 10 to the 7 seconds. That's what we said in the very first lecture of this semester, so it's a very good rule of thumb, and more accurately though, 3.16 times 10 to the 7 seconds. Sounds good. So if we were to rearrange Kepler's third law and solve for the mass of the Sun, we would have the mass of the Sun is equal to 4 pi squared divided by g radius cubed divided by the period squared. All we're doing is just bringing the m over to the left and the t squared over to the right. So in this case, the mass of the Sun is equal to 4 pi squared over g, 6.67 times 10 to the minus 11. And then we have the radius of the Earth's orbit, 1.5 times 10 to the 11. We're going to cube that over the period of the Earth's orbit, 3.16 times 10 to the 7, that value squared, and this is equal to 2.00 times 10 to the 30 kilograms. 2.00 times 10 to the 30 kilograms is the mass of the Sun by Kepler's third law. Can you determine the mass of the Earth from this data? No, because nowhere in Kepler's third law is the mass of the satellite involved. This is kind of a simplification in the case where one body is really large compared to the other body. If we were to find the true two-mass, two-body situation, then the mass of the Earth would come into play, but we're not using that for Kepler's third law. The Earth is just too small compared to the Sun. So in this case, we cannot determine the mass of the Earth from this particular data.